So good morning, my name is Chris Jordan. I'm the CEO for the Fluency Security. Fluency is a SIM, a Security Information Event Management System, that's been doing work in real-time work since we started, 10 years. And that's an important concept, that we actually do everything in real time. So a lot of our awards, our RSA Sandbox finalists, all came from the fact that we were fast and very scalable. But what does a SIM have to do with observability? And that's what we're here to talk about. But it is important to understand that I come from an operational background. And so what I mean by that is, so in the 90s, I made a change from doing what at the time was called offensive or red teaming to defensive work. I started the Army Computer Emergency Response Team back in 1997, one of the original 4 members. And then I went over to the DoD DISAssist and changed that to the DoD CERT, did a number of operations there, FAA, JP Morgan, DuPont, DTRA. So I started a large number of computer emergency response teams and security operations centers. In 2003, I started doing research work for the NSA, had a company, and that company was purchased by McAfee. And for 3 years, I was the vice president in charge of threat intelligence for McAfee, helping them improve their products on the desktop. I was mostly a networking guy up to that point. Unfortunately, McAfee and I kind of went our separate ways. I got into big data. I thought big data was the future of security, that more and more systems were producing data. In fact, data has itself its own Moore's law. Every 24 months, every 2 years, the amount of data in the world doubles. Right? So in the next 2 years, we're going to produce more data than we actually have to this point looking back in time. Now, a lot of things are occurring for that reason. One of the reasons is the fact that we have more processing power, more ability to compute and to create data, right? Our data types are becoming more dense. We have video now, right? We have complex amounts of information. And so our data is growing leaps and bounds. And in fact, if you were to build a system today and you say, this is how much I need today, the odds are you're going to need twice as much of that in 2 years. So we have to find more efficient ways of evaluating data, getting through the data to find issues. And that's important because the more we search, the more we look, the more time it takes. And unfortunately, especially in security, we need to be real time. We need to operate faster. In fact, there's a rule in CrowdStrike called the 1-10-60 rule. 1 minute to detect, 10 minutes to acknowledge, 60 minutes to resolve. And so if we're searching a database, and I'll say this over and over again, we're losing not only that 1 minute to detect, most observation capabilities are occurring every 15 minutes to every hour. You've already lost the game if you're using observability for security purposes. Some of the other things we need to do better in our industry that we focus on in our company is we actually focus on writing code. We actually have a processing language. In fact, the big companies, both Sumo and Splunk, have processing languages. And it's important because it allows us to scale knowledge. It allows us to address issues of manpower, right? As people leave an organization, we have to backfill them, and that knowledge leaves. We spend so much time training our people, but our people leave. So we have to have a way of capturing that knowledge and scaling that knowledge. Now, why is scaling important? It's because as you move to 7 by 24-hour operations, each seat in your operations is actually 6 people, right? You need 3 people during the week, 2 people on the weekend, and a duty officer. That's 6 people, right? And they cover such things as also holidays. So it's very expensive to go operational for 7 by 24, and finding the manpower to do it requires us to be able to enhance them, right? And lastly, like I said, timing is everything. We're going 7 by 24 because we need to respond to things immediately. So we can't be searching a database and slowing ourselves down. And so we focus on these things. The other thing we focus on is getting as much information in front of people as possible. So observability, when we're going to hit a point called full stack observability, we're going to be talking about how do I resolve issues. So these are all kind of things to go on when we take a look at observability. Now let's talk about marketing for a second. All right, now we have all the vendors, I'm a vendor, all the vendors in this room, and vendors talk a marketing language. And unfortunately, a marketing language, this is a technical track, marketing language sometimes doesn't coincide with technology. And observability is a great example. Right now, if you go on the internet and you were to search for observability, you'll find that observability, the answer is logs, metrics, and traces. It's very data-centric. It's more interested in saying you can get this data and you can analyze this data, right? And the most common things is to show you as a trace log, and this is a trace log output from another product, and that's by far the way they say we can do observability. If I can do a trace log, I can do observability. But observability is not about data. It's about having a solution. It's about saying, what does this trace log mean? How do I close it? And does this process mean anything to my business? And this is the big jump. So observability is real time. That's the most important aspect when you take a look at observability. So as you move forward, you're going to find that this is going to be one of the bigger changes in the security industry, is this focus around observability. Splunk just paid $2 billion for SignalFX to get this capability, a very limited capability, right? Good product, but it's limited. Datadog has a monitoring capability, limited, but they're in the game. There's very few people in the game of observability, but the reason why you see it a lot is because it's a very hot marketing term, and people will say, well, I do logs, I'll call myself observability. But that's not what observability is. Observability is a little bit different, right? It's how do I be able to monitor and alert and investigate in real time? Now, why is this a hot term? Why is observability all of a sudden becoming something important? One of the reasons is the cloud. I would take it most of the organizations today have some cloud presence, whether it's Office 365, Salesforce.com, maybe you're using AWS and Azure directly. The problem with cloud is you don't own it. You can't use Nagios to scan it. You can't use any of the old tools to monitor your cloud network. So the cloud providers provide you AWS, like AWS, provide you metric APIs into the infrastructure to see basic data. So it might be a metric. It might be saying, hey, my CPU has this temperature. It has this much processing power being used. But what it's not giving you is a metric, right? A true metric. A true metric is historical. It compares itself against another point in time. So we have an infrastructure that we no longer control, and we're barely getting metrics out of it. And we've got to change those metrics into a means of operating, right? And so the first thing that you're going to wind up doing is you're going to change probably the most common thing we do in security today, search. If you were to take a look at every SIEM today in the marketplace, the first thing they do is they talk about their database. In fact, some of the SIEMs out there, Datadog, database, Elastic, database, are databases, right? We're stuck in a world of searching. It's not a great world to be in. So I'll give you a good example. We have so many people in the room right now. And if I want to count how many people in the room, it's good, doors are shut, I can count everybody. But if the doors are open and people are coming and going, and I want to know how many people in the room, and let's say I have a limit of 50 people, how do I know when to hit that limit? Right? Any kid can tell you, it's pretty simple. I just stand at the door and I increment when someone walks in and decrement when someone leaves. Right? That's watching. That's not searching. The child never looked in the room and counted anybody. It's a completely different model. It's a simpler model. It's a real-time model. It lets me know exactly how many people are in there at any time, and it takes less effort. But strangely, we don't do it often. Why? Because we love databases. Right? And we're going to get into why we love databases later on, but it's important to understand that observability is not just a different term, it's a completely different technology. Right? So if you have something that's 4 or 5 years old, the odds of it using observability are fairly slim, pretty much zero. Right? The concept of streaming analytics isn't very big. In fact, if I was to use the term data lake, everybody's heard of it. Ask yourself if you ever heard of a data river. Okay? Observability, streaming analytics is something that, for the most part, is not discussed in the commercial industry. And it's really simple. Right? It's sometimes a simple change is a huge change. Take the sewing machine, right? Singer came out with a sewing machine. The invention they had was to put the hole in the front of the needle. That's simple. Changed everything. Allowed us to automate sewing, right? A change of perspective is huge, right? So I use the term watch, but technically it's listen, right? So the system is going to listen. In fact, if any of you guys are programmers, you might actually know the listen command. And it shows up in interfaces, right? And there's a reason, because listening is an interrupt-based technology. What that means is that you're going to be doing something else, and then you get interrupted and you say, I need to update something. Just like when someone walked in and out of the room, when I increment and decrement, it's because I've had an interrupt. The state has changed. So how does it look? So if we take a look at AWS, there actually is a thing called CloudWatch Metric Insights. Right? It's actually a function at the AWS level. So another issue around cloud is probably the worst thing ever to be created was somebody created this slogan, the cloud is someone else's computer. It's the worst thing that ever came out. And the reason is the cloud is not someone else's computer. Right? If you take a look at the AWS infrastructure, you have ECS, ECS. You have EC2. EC2 is your computational capability. S3, that's your data bucket. Glacier, that's another data bucket. Right? The way even your network is charged differently. Every element is charged separately and acquired separately. It's not a machine. You're buying parts of a machine and putting it together. That's a little bit different than what we've ever done before. Okay? So then you have to say to yourself, I have this thing, it's in the cloud, I've got APIs to get the data, I'm analyzing it, and now I have to manage it. How do you know when a service goes down in the cloud? Right? You have to be pulling that metric all the time, kind of, but just because you have 0 CPU doesn't mean it's down. Right? So there's other things you have to take a look at. It might just be a blip. It might just be a missed message. So that's the reason why historical is important. You need to see it kind of in a row to know something's wrong. You might want to say when the capacity is greater than 80% over a 3-minute period of time. We'll talk about ticks, but that's 3 ticks. So it was funny because yesterday I was with a customer, and we were just talking about this. They had a system go down. I said, how did you know the system went down? The customer called me. Okay? That's like the worst answer, right? And in today's systems, we search for it. Most searches to determine down systems are done once an hour, right? We're just hoping nobody goes and visits or uses our machine over that hour, okay? And finally, you could monitor it, right? And in fact, that's the kind of the right answer we should be doing. We should be monitoring performance, okay? Now, what does it kind of look like to monitor? It's actually not that hard. This is our language, but basically, you're going to see it says, hey, I'm going to define a CPU as a metric. That metric EC2, right? That's an AWS.CPU. That's the call for AWS. I'm going to look for things that have the application I'm interested in that equals analytic, and then I'm going to basically publish it, and I'm going to do an alert when this attribute is hit. Okay? And you're going to see that it has such things as like 5 minutes, right? So we're going to cover what is an analytic, but an analytic covers more than just what a search would have covered. Okay, there is time frame is involved with analytics. So let's talk about what we're observing. We're observing a message. And this is really basic, but it's important to understand the basics. So a message comes in, and I'm going to listen to it. Now, the message kind of shows up in a sleeve. We don't know, we have the message itself and the content of that message. And we're going to grab that content, and we're going to examine and listen into it. And that we're going to react to. In fact, one of the better structures out there for observability is the ReactX structure, right? React. That's our interrupt. That's when a person enters or leaves. And so we listen to that, we might update our metrics, and we generate an alert. And that's all real time. That's what you're used to. Then later on, we're going to store it, and we do 2 things with stored data. We're going to go ahead and say, I need a report, or I might have to investigate something. Remember I said full stack. Now let's chew this a little bit different and make an easy analogy for you. Think about music. Okay? If I have something and it's being played, I'm listening to it, it's how do I do it? So I said music, but let's do a phone call first. I need to talk to you. That's a message. I call you. That's an interrupt. Your phone rings, right? You respond to that interrupt. This is a type of interface you're used to. You get notifications today on your iPhones. Those are interrupts, right? Your iPhone is listening to an application. It gets a message, and it triggers a reaction, right? Interfaces are highly reactive. So that's the first type. The second one is you say, you know what? I want to listen to a song and I want to grab it on demand, right? Or maybe I have a recorded voicemail. At that point there, I'm doing an ad hoc. I am generating, that's the query. That's the world we're used to living in. I'm querying it. I'm getting data back. And then finally, the last way we consume data is by schedule. Think about TVs and radio stations. You're not picking the content. You're picking when you're listening. I know the show's at 8 o'clock on Thursday night. I listen at that point. I watch at that time. Okay? That's scheduled oriented. And those three basic capabilities, right? The reactive, the ad hoc, and the scheduled is the way we interact with data. And that's how we want to build our system or build our analysis with. So that comes up with, if we can do all three of those, we consider ourselves full stack. Okay? Now, I made the data lake part here really easy because everybody understands ad hoc querying and searching and reports. But data river is a little bit different because we can't really live at the moment. People sometimes like to put the word near in front of real time. Near real time, right? Your brain actually is milliseconds behind reality all the time. We don't say that you're near real time. Okay? Real time means that the data is coming in and we're dealing with it when we see it. And we do this by first generating a tick. So we're going to put everything into a tick, okay? And those ticks are going to have buckets or rules. So I might say, I want to know about that CPU. You saw that rule. It's going to generate a bucket, and as information comes in, it's going to update the state for that tick. And then when it's done with that tick, it publishes it. Now, it can save it locally, it can evaluate it, but it's going to publish it. Now, how many things are in that rule is called the dimension. So if you have 100 servers and you're looking at the CPU for 100 servers, you have a dimension of 100. Now I'm bringing this up because this is how you're going to buy things. This is how you look at observability, and these are the way you structure it and say, that's how I'm going to buy it. And so when I'm looking at infrastructure, I want to be able to grab the data, I want to do those three functions, and then I need to be able to create a system that's going to alert, and these are the limits by which, it's pretty simple, by which we evaluate the strength of an observable system, right? Dimensions, how many systems I can handle, right? I've said our company's been doing this for 10 years. We can actually handle millions in our dimensions, right? Datadog can handle less than 1,000. Splunk can handle less than 5,000, which means if you have less than 5,000 employees, less than 5,000 systems, Splunk works. You have 5,001, it doesn't. Okay, that's the dimensions. The buckets is the number of rules. We can handle thousands, right? Most systems handle about 100 buckets, right? And the reason why our numbers are so good is we've been living this for 8 years. And then finally, our tick range. This one here is important because you pay for the tick. So every API call you do in the cloud, you pay for. They're not free. So in the case of AWS, if you decide to have a tick every minute, you're going to find out you have a very big bill if you're looking at all 140 metrics every minute. So when you take a look at when you're purchasing and when you're structuring observability, just look at these three things and understand their impact. You want things to be fast, you want them to be quick, but like everything else in the cloud, you pay for it. Okay. Now, what is in a rule or what is in a bucket when it comes to observability, and how does it separate itself from filtering? So there's a couple of technologies. There's Skylar, which is SentinelOne's, Humio, which is just CrowdStrike. Their technology is not analytics, it's filtering. It's key value pairing of a record that comes in, it's parsed, and then they're going to go say, I select it, and then the trigger is to make an announcement when there's a match, right? Now, if you maintain state, that means you know about time. So remember I said tick. If there's a tick, you have a time frame, okay? That's important because once you have a time frame, you can perform math. You can do aggregations. You can say, give me the max, give me the min, give me the average, right? All these things are important for metrics because I want to say, tell me when there's an 80% load on my wire for more than 3 minutes, right? So those are important. Time frame aggregation is what separates analytics from filtering. Filtering is a simple route. I grab a packet, I parse it, I do key value pairing, and then I route it as a message. Okay. So as I look at processing, I divide this in one piece, is that we actually have to have a language that backs it up. So we have a different language. Splunk and Sumo, another decent product, both have processing languages. It's confusing because they both call it Sumo processing language, Splunk processing language. They're both SPL. We're lucky we don't begin with S, so ours is FPL. And that's actually done on the data lake. And it's mostly based, theirs are based on SQL, ours are based on modern programming languages. SQL was built in 1979, and there's a lot that's changed in programming since 1979, right? We now have object-oriented, we have an understanding of objects in general, function-oriented programming, and so we've absorbed that into our language because we found that easier. In fact, that example I showed you looked probably easier to you than an SQL call, right? And that's because it's more natural to talk in a processing language than it is in a query language, okay? But the key is that we actually have to have a reactive-X version of the same language. And the big difference is, of course, there's a listen command, right? I'm going to listen to something. In us, we use the let command, but let is listen. All right, now I'm going to get a little bit more technical, and then we're going to get really technical. ETL, ELT. There's a big, huge push for ELT. ELT is, you probably know it, Kafka. It's our ability to move data from one system into a database. And it's called ELT because we extract the data, we load it into a database, we do a search, and then we transform it. And what transform means is I'm going to parse it. I'm going to change my data, right? So in an ELT world, I grab all the data, I transform it, and then I search for what I want to search. In an ETL world, I'm going to transfer my data. I'm going to modify it before I even store it, right? So most sites like Splunk will do an ETLT. They'll actually do some transformation ahead of time because they want to index certain fields, right? So what our transformation looks like, we'll go back, we can flip back and forth. These are what transformations are. I need to parse data. Now, why is that important? If I need to understand from observability, I'm looking at an outage. If I parse the data, I can find the word outage in it, I can tag that data as outage. It's much easier for me to track something if I can parse the data. So I have to do the transformation ahead of time if I want to do it in real time. Calculating fields. If I don't parse, I can't calculate it, but on top of it, doing the calculation in the field, that's actually part of transformation, right? Data correction, right? Things like error checking, validation, type manipulation. It's crazy, I hate to tell you, but there's a lot of work being done about normalizing data, and you hear it, and there's 3 basics to normalizing. I got to change my field name, I got to change my validate and change the data, and then I actually have to validate and change the data type, right? And then do an error check. So there's a lot to correcting data. And all of that is being done on the fly. Decoration, GeoIP lookups. People think of it all the time. Anything that you think of a SOAR product doing, it can be done before you even put it in the database. That's decoration. I'm adding to the record. And then finally, security. I scrub data. Things like pseudonymization, which is basically GDPR. The ability of taking your name out of the data before it's stored, or changing that to a token that can be deleted later on, right? All of that capability is the transformation capability. And the reason why you see ELT and not ETL is because the more work you do before you load it in, the more work you have to do. The more likely you're going to have a failure, and the data record is not going to be stored. So the belief is if I don't do my transformation, if I just store it, I can transfer it later. The problem is you pay for it. The more you need to look at that record, the more you have to process it again. The more inefficient the overall processing number is. Why is efficiency important? I'll kind of wrap it up on this one, on this level. Efficiency, which we hear all the time, but we don't understand why is it important in the cloud. It's because you pay for everything in the cloud. The more processing power you pay, you have to pay for it. The more networking, you have to pay for it. The more storage, you have to pay for it. So when you're inefficient in the cloud, it still works. You just don't have as much money. Okay, so we were dealing with an Army research lab, and they wanted to do a process. They looked at us, that's too much money. They had a budget that was $500,000. They spent it in 1 month in AWS. What happened was AWS doesn't give their bill to the end of the month. They had no clue how much processing power they were using till the end of the month. They spent it all, right? That's nothing unusual, right? So that's some of the things about, again, real-time monitoring. We actually can do monitoring over your AWS billing to warn you that you're spending too much money on your AWS billing. We saved about $60,000 with one of our analysts taking a look at our own data and realized that we weren't reserving enough instances, right? So that's something that you have to be able to do with AWS, any cloud, but AWS in particular, is you have to be able to understand your efficiency, because your cost is your efficiency, right? Efficient code is better for you because it costs less money. All right, so we go into this observability, we go into alerts, and what I'm going to do on the second half of this is talk about indicators, because there was the brief around the whole conference is around intelligence. And so as data comes into our system, we can write observation alerts that say, this is a problem. And so how many people have seen the MITRE ATT&CK stuff? Everybody familiar with the MITRE ATT&CK? Oh, that's scary. Okay, so MITRE ATT&CK is the second generation. The first one was CVE. That had to do with vulnerabilities. The problem with it was people were trying to defend their networks using CVEs. But they were trying to say this attack, their signature, was this CVE. But it had no CVE. It had nothing to do with a vulnerability. It had everything to do with a tactic or a technique to exploit something. And so they took a step back and they said, you know what, maybe what we need to do is come up with this different framework to talk about attacking. And so now we have an alert that comes in that we can observe. We can label it something. This is one piece of malware being analyzed. And you can see all the different tactics and techniques associated with it, right? Why is that important? Let's say you have a piece of malware. You think it's malware. And remember I told you it's important that we need to close something. And so I need to validate, was this really malware? How do I do it? I take it, I run it in a sandbox, and I get a result like this, and I say, yeah, that's malware. But that means I have the virus. I mean, it means I have a copy of that file, and I can run it in an environment that allows it to completely execute. If you've been to enough hacker conventions, you're going to find out that running it in a sandbox is pretty tough, and getting consistent results like this would be really almost impossible. So what happens is that we're going to use your actual events on your network to determine these alerts. So what happens is something triggers, and it's going to generate these indicators. I'm going to look up that hash file, and I say, I don't know that hash, but I don't know that file either. What are its indicators? What are its behaviors? So observability is part of EDRs. So let's think about that. What is actually on your machine when you buy an EDR? It's not an EDR, actually. It's an EPP, an endpoint protection software. If you were to remove the internet, you basically have glorified antivirus. That's it. Without the internet, EDR is EPP. Okay? There's two pieces of data that leave that EDR. One are the alerts. That's what you're used to seeing. But there's another one, the raw events. Unless you're paying extra money, it used to be called Hermes, it's now called CloudFunnel and SentinelOne. It's called FDR and CrowdStrike. That's the raw data. You're getting between 500 megs to 1.5 gigabytes of data per day per machine leaving your network. It's happening right now anyways. You can pay for it and see it, but that, when someone says, oh my gosh, if I turn that on, it's going to hurt my network. It's already turned on. Does your network degrade? No. The reason is because most people use only 10% of their outbound. Most of the stuff in a network is inbound. You're consuming more than you produce. Okay? So anyway, so this data comes in. I say, hey, I see this file. Is this bad? And what it's going to do is it's first going to act like the AV. It's already done the AV work. But now it's going to validate it. It's going to go back to the raw data, and it's going to search it. Remember this full stack. I'm getting the alert from the EPP. That's the observability. I listen, I trigger. Now I do an ad hoc search, and I say, give me the last 5 minutes of this machine. And then I'm going to compare it against all indicators known. And I say, oh my gosh, look at all these other indicators. I think this thing's bad. I'm going to do one last check. Are you on a whitelist? And if you're not on a whitelist, I go ahead and say you're bad. And then you're going to have to override me. That's how EDR works today. So when people say there's no difference between EDR and EPP, there's a huge difference. It's that difference. Now, what happens if you can't afford EDR? Okay? Or maybe your system's so old it can't use EDR. Well, we can do some tricks. So I've said a lot about AWS, and AWS has this CloudWatch and CloudTrail, and you put CloudTrail agents to get data out of your nodes and your buckets in AWS. In Azure, Microsoft is standardized on Sysmon. Sneaky. People don't really talk about it. So Sysmon basically tells me everything my machine's doing. It tells me all my processes, it tells me when to open up sockets, it tells me my command lines. Okay, that's my raw data coming from a machine. It's not as dense as EDR data. The EDR streaming data, like I told you, was between 5 and 1.5. We found Sysmon to be around 300 megs to about 800 megs of data. It's actually a lot lighter. It doesn't have as much data in it, but it has crucial data. And so the data can come out. You have your EPP doing an alert. Now I have a trigger. What I can do is I can now watch the data, right, or listen to the data, and I can grab those indicators. Now you're going, man, I can't write all those indicators. Well, Florian, if you follow him on Twitter, has done a great job on these things called Sigma rules. And they're in the Yara format. It's the same format that Chronicle uses for the most part for it. And basically, these Sigma rules allow me to look at, they're basically a filter. They allow me to look at an instance and say, I found an indicator. I can now take that indicator, make an alert, and then when an EPP triggers and says, I'm looking at this, I don't know what this file is, can you tell me? I can now confirm it with indicators. This is kind of what the computer sees. This is us just using our stuff. And there's a couple things going on, but the key here is that this is observability. I'm observing stuff coming in. I've added indicators to it. And then when I have the trigger event, I can then compare it to the indicators and score it. Now, why is it I just don't look at indicators? So this one here is Big Fix. It's a good guy. It just happens to create a temp directory. Put its executable in a temp directory. Unzip it with a common hacker unzip file. Runs it, stops your audit trail, modifies your audit trail, turns your audit trail back on after it's done with this assessment. It looks like a virus. It has all the right indicators. That's the reason why you do that last trick, the whitelist. There's a couple other things going on here. As you can see on this one, that little red and yellow kind of thing off to the side, that little bell, those are scoping. We didn't get into scoping, but that's behavior. So with indicators and alerts, we actually have behavior associated with it. This is the first time I've seen it for this machine. This is the first time I've seen it for my company, right? This is the first time I've seen it in the region. Scoping is fairly important. To take a step back and go into what detection is all about, one of the things about detection is a fault in a system. And there's actually an entire science around fault management. Faults do not occur by themselves. Indicators do not occur by themselves. Viruses don't have one indicator that triggers. They have tons of indicators that trigger. You saw that McAfee picture of Trellix in the sandbox, all those indicators that triggered for that virus, right? That's exactly what you're looking for, supporting vectors. So when your analyst gets something and say, is this a real alert? That's really not hard to take a look at. That's definitely something that needs to be evaluated. If it is very quickly evaluated, I can take that hash, I can even see the file name, I can figure out, is this real or not? And if it's not something I know, then it's something I should stop. Pretty simple. Okay? This is the hardest thing any operations does, is validating an event. Think about it. You get tons of, everybody talks about false positive, not important. Really not important. Everybody talks about training people. But the biggest issue is actually, how do you close an event? How do you validate it? How do you respond to it? Right? These are the things that kind of change when you get into monitoring, right? The reality is that we have to focus on is the easy alerts are, hey, my machine's down. This is the hard stuff. And this winds up in security all the time. So I kind of leave that piece to you, is to say, what is observability? What's the future of observability? And to me, it's indicators. It's not just the machine's up or the machine's down, right? That's what, trust me, you need it. That's something we do, but it's something you have to think about. And then lastly, how do we kind of capture data? And we capture data, in our case here, we capture processes. We have that FPL, and that's what you see on one side. And the other side, that's the dashboard it creates. Now, why is that important? And I told you, it's because I want to capture as much as I can in processes. My investigation's the same way. We actually have the script that says, hey, if I see this hash, tell me everywhere it's been in my organization, who's ever touched it, whatever machines have touched it, and give me its history. Because give me every ticket that's ever addressed this hash before, and how was that handled? You can see that the average person can handle this type of information. What they can't handle is, given a SHA-256, is this good or bad? I'll tell you, most analysts, when they see a SHA-256, and that's the only thing they have, they type it in the virus total, they see the score, and they say yay or nay, and they open or close it based upon what was in virus total. It's an utter fail. Okay? All right. So last thing, I kind of wrap it up with this one. The last thing I kind of talk about is, listen, I talk about observability and structures around observability. Told you that we do SIM work. But before you even get there, what I find most of the time when I deal with customers is they actually don't have an information infrastructure. How do you get to a point of being able to leverage observability? How do you get to a point of leveraging a SIM? And so you could do this all in 1 month. I put 120 days. I tell people it's best to have a success each month to tell management, instead of, you can get 4 months, and then by the 5th month, they're going to get used to it, and you can show them trending, right? So the first thing you have to do is, remember, observability is about listening to the streams. You have to get all the data sources. So go through your infrastructure and create a list of everything that generates audit. Salesforce.com, Zoom, right? Azure, AWS, your servers, your email. Okay, all that stuff generates data. And the first thing you want to do is create a list of data that's coming in, get it parsed, and get it into the system. And once you have that, then you're going to go to the next level, and that's, what are my entities? Now, we like to say it's my users and my machines. I really stress services. As the future goes forward, You're not going to have systems all the time. You already know about containers. Those are services. So instead of thinking of everything as machines, think about services. You want to know your assets, your users, and your services. That's the next stage. Now, if you got that, then do a vulnerability assessment. Now, if you hire security people, they like to do the vulnerability assessment first. But how can you do an assessment over something you don't know exists? You need to get your asset lists. You need to be able to then have that list, and that's what the assessment goes against. Right? Some of the things we were talking about, like with FPL, is we can see if there's an agent on that machine. One of the agents is, does that machine have, if it's a server, a Nessus agent, so it can scan internally? Right? Is it running AV? These are all things that you can do. You can go to get a resource, run it, analyze it. Now you have that structure. Finally, when you're done with all that, then you monitor. Then you have the capability of now setting up processes to discover and close issues. But until you have an infrastructure, you're piecemealing it. You're saying, oh, I grab my network data, I'll review my network data. Right? I'll grab my antivirus and I'll review my antivirus. And then when you get compromised, you say, oh, you know what we didn't do? We didn't check the VPN logs. Now let's add the VPN. We all know about Twitter. Take some time to read what Peter Zatko with Mudge talked about Twitter. He said they were 10 years behind. They were like 20 years behind. They didn't even review their own internal audit logs of people trying to log in and failing from different countries to infrastructures they weren't supposed to get to. The ability of seeing your infrastructure is the basis of security. Without any awareness, there's nothing to monitor. There's nothing to see. All right, that's kind of like, I like this slide the most. I know it had nothing to do with observability, but for most people, this is going to be the most important thing that you're going to do. You're going to make sure you stand up an infrastructure, see your infrastructure, and then each one of those steps, report. And then what happens month 5, continuous monitoring. What's going to happen is you're going to say, here's a new asset. Here's a new data feed I discovered. Right? This is my volume of data feed. This is how much is increasing. Then my assets. Here's my new assets. Here's my assets that left. Somebody get fired. Did that asset disappear? That's SOC 2 compliance. Well, part of SOC 2. That's not the only thing for SOC 2. Right? Then you say, hey, is it scanned? Right? I have a new machine in my network. Has it been scanned? Is it patched? Right? What's its vulnerability that's adding to me? And finally, like I said, monitor how many tickets were open, how many tickets were closed, how many tickets were repetitive. Right? So the point is that the majority of things at the C level that you want to brief on and the majority of information you want to give to your management comes from establishing an infrastructure. And then what observability does is just a better form of executing. Right? So the first thing you want to do is learn to walk before you run. Then you can start running. Then you can start doing observability. But you can't do that until you first set up an infrastructure. And yes, pieces will change. Okay? That's okay. Right? Because it's getting easier to buy this type of stuff than it is to buy, leapfrog and go into something you can't handle. That's it. I appreciate your time. Yeah. So the question is looking at the costing of AWS versus Office 365 or Azure. So in the case of its dynamic allocations, don't really occur as much in the Azure world. Now, in the Google Cloud, yeah. But in the Azure, no. So you could do the same thing. You could poll it. You don't have to poll it as often. You could poll it, look at the start times, and compute your billing that way. But with dynamic resources, that's where the real billing issue comes into play. If you have something that says, I'm going to create 20 machines for 1 minute and tear them down, that's where the real issue comes into play. So you can do Azure and do billing in real time with Azure, but AWS's billing has been, for most people who have been paying AWS bills, it's every time it's a surprise, right? In fact, when you take a look at your billing screen, you'll see there's an asterisk, usually for 7 days prior till it finalizes. And that's per day. So sometimes it's up to weeks. AWS doesn't even know how much to charge you for a couple days. So, what's your second? Network Detection Response Service, NDR? Oh, MDR. Okay, so yeah, that's more of a business question. The business question is, do we partner with MSSP, SOCs? And the answer is yes. Now, and the reason is I believe that companies have to be pure plays, right? And what I mean is that if I stood up a SOC capability, I wouldn't have SOC partners, right? And I like SOC. We're a SaaS product. What that means is you don't have to have an admin. Somebody laughed at me. You don't. Oh, you always have, no, you don't have to have it. You don't do backups, right? All you do is add users, delete users. If that's an admin job that has to be full-time, I want that job, okay? When you're a SaaS model, it's not that bad. However, there's still a learning curve. With any product, you have to learn how to use it, and especially when you're evaluating data. My personal opinion is that most companies don't have a career path that they could sustain analysts. If you're Wells Fargo, if you're a large organization, a bank, you'll have enough people to stand up your own SOC. Now you think AWS must have their own, so they kind of do. They pay CrowdStrike. Okay, so the reality is that you want when it comes down to SOC, hours and experience matter. It's like hours behind flying. And so for us, we like to team up with MSSPs. We have 6 that we're teaming up. We're looking at 3 more in South Africa right now. We're talking to a couple others in the States. We like partners. And the reason is because we think that MSSPs and MSPs are crucial to companies being better security. They just don't, like I said, they can't have the career path. They don't get the same amount of time unless their organization is really that big. And I also don't believe in creating your own tools. When I did SOCs, we created them because we just didn't have the tools. But right now, the industry is creating an incredible amount of tools, especially around security. And I don't think, and I'm not a big SOAR believer, to kind of go down that route of MSSPs. Why can't I automate it? I had another briefing that I kind of tore up before this one, and I talk about people running SOARs and the fact that it's useless. If you think that you have better knowledge than these billion-dollar companies, oh, I'm going to do the MD5 or a hash lookup. Believe it or not, all the AVs have already done that, right? Your AV has failed. You're only looking to say, does another AV think this is bad at this point? The same thing with DNSs. Oh, I'm going to look up all the domain names. Just get Cisco Umbrella. It will filter them out. They won't even go into your organization, right? It's tuned. It'll be dropped. Most reputation stuff can be dropped. Is there value to reputation services? Yes, in hindsight. An alert comes out, you have a problem, you can then go back into your data and look into the past. A hacker cannot change the past. The MD5 is going to be there. The SHA-256 is going to be there, right? The file name is going to be there. If they're that much consistent, their indicators are going to exist in the past, but they're not going to exist in the future. They disappear within 24 to 48 hours. Right? It's worse than milk. I used to call it milk. It's not even milk anymore. Okay? It's like fish, sushi fish. You don't want to eat it 48 hours on a desktop, right? And it's the same thing with reputation. So when you take a look at operations and building your own, and it's a long answer to a short question, but I'm a big believer in MSPs and MSSPs. And the difference to me is an MSP is going to sell you security stuff, and MSSP is going to run it for you. And I do prefer the ones that run it for you. Now, that doesn't mean you shouldn't validate them. You should run your own. You should be able to have transparency. You have to have a couple smart people on your staff to review it. That I agree with, right? And you're going to find that when you review it, sometimes you're going to say, man, these people suck. And you just have to get another one, right? So do a 1-year deal before you do a 3-year deal. I would say that too. All right. Any more questions? All right. I take other questions besides observability, obviously, but okay. Thank you very much. Appreciate it.